Hello, I am Dr. Uksung Kim. In this video, we will be discussing the support and reactive forces. This slide shows the overview of my lecture. In the beginning, I will talk about the common types of support and unknown reactions. Then, using an example problem, you will learn about how to draw free body diagrams, formulate equilibrium equations, and find unknown support reactions. Finally, I will provide a practice problem to check the level of your understanding related to this topic. There are three common types of support, which are roller, pin, and fixed support. A roller support can move horizontally and rotate, but cannot move vertically. Think about it, the golf bag stand. So you remove this one and then apply the loading horizontally, it will move horizontally. And then also apply the moment over here in the rotate, it will rotate. But you applied loading vertically, okay? But it cannot move vertically. So that is a good example of roller support. And this picture shows the rollers and associated bearing pads using a highway bridge. In this slide, you can see that this symbol represents the roller support, and others also use this symbol as a roller support too. So triangle, and underneath there's a two wheels. And then in this case, I already mentioned to you, can move horizontally and rotate, but cannot move vertically. So there is only one reaction, BA, for roller support. So there's only one reaction, vertical direction, so B, and then A. A pin support can rotate, but cannot move horizontally and vertically. So there are two reactions in this case. So we will see this one. So this is a seesaw at playground. You apply the loading in this portion, especially focus on that horizontally cannot move, right? And then vertically cannot move, but apply the moment, it will rotate. So that is the good example of pin support. And this picture shows a steel pin support. You can see that this symbol represents the pin support. So as I mentioned, there are two unknown reactions, HA and BA, for the pin support. So there is a horizontal direction and then vertical direction of the unknown reactions. A fixed support cannot rotate and cannot move horizontally and vertically. So this is a wall hook. Maybe you can check that at your room. You try to apply load over here in the horizontally and try to move, cannot move. And then vertically cannot move. Apply the moment, cannot rotate. So that one is that the fixed support. And this photo shows welded floor beams of a building. So this is a symbol for fixed support. And then there are three support reactions, unknown reactions for fixed support, BA, HA, BA, and MA. So that one is the HA, for the horizontal one, the BA, right? There is a MA. So that is the unknown reactions. So we talk about the three common types of support: roller, pin, and fixed support. So an example problem is given in this slide. So we need to determine the reactions at the support A and the B. So let's try to draw a free body diagram. So A is the pin support, B is the roller support. So I draw the free body diagram, okay? To think about it. This pin support is A, so there's two unknown reactions, right? We learned about that. So there's a HA and then BA. And then B is at the roller, so there's only one unknown reaction. So B, this one, okay? So in this one, you also think about there's a uniformly distributed load. So you can make a concentrate load. So that is at the 80 times 8, that is 640 pound. And then don't forget for the external moment, that one is at the 500 feet-pound. Okay, so we put the all external load and the unknown reactions, and then don't forget put the dimensions and distance. So that distance is at the from here to here. That is at the applied load in the middle of the display load. So there's a 4 feet, right? And then the total is at the 18 feet. So there's a remaining distance is at the 14 feet, right? And then from the moment to the B, that is the 5 feet. Okay, and then also for the reaction part of that HA, sometimes you can write down the A, X, because the horizontal direction of the reaction at the support A. And then this one, you can write down the A, Y. And then this one, you can write down also the B, sorry, B, and then B, Y. Okay, so you can write down this one also. So this is the free body diagram, okay? And the next step is to formulate the equilibrium equations. So sigma f x equals 0, sigma f y equals 0, and sigma m equals 0, right? So that one we can apply this equilibrium equation to solve the reactions for this problem. And then you can say we already draw the free body diagram. Okay, it's very easy to formulate the equilibrium equation using this free body diagram. So sigma fx equals 0. And then this diagram, you can see that there's only AX. So AX equals 0. So there's a very easy one. And then sigma Fy equals 0. Okay. And then there is a positive direction for each one. And then sigma Fy equals 0. So there's a AY, you can see that, right? And then another one is at the downward 640. And then moment you cannot add it. 500, there's a moment, right? And then plus BY equal 0. So this one gives AY plus BY equal 640. And then moment is very important. So sigma MA equals 0. And then sign convention, counterclockwise moment, there's a positive. And then there's a pivot point is A, so that is the pivot point. So AX, AY cannot create a moment because there is no moment arm. So 640 times moment arm is that the 4. That's correct. And then this one about the A, and then moment is that the clockwise. So there's a minus. And then 500 feet-pound, there's a moment itself. So there's a clockwise. So minus 500. And then you don't need to multiply the distance because there is a moment itself. And then BY times, and then total distance is that the 18, right? And then that is also, that is actually gives a counterclockwise moment. So that one is at the positive. That one equals 0. So with this one, you can formulate this one 18 BY equal, you add this one, you can get the 3060. So that is the formulation of equilibrium equations. Now, finally, determine the reactions at the support A and B using the equilibrium equations. So this one, we already have this one from the previous step, right? So AX, that is very simple because that is a 0, right? So there's a 0 pound, so that one is the one answer for this one. And then sigma Fy, there's a 2 actually unknowns, but the sigma MA, you can get the By directly because the By value is that the 3060 divided by 18. You can get the By value is 170 pounds. Then your answer should be boxed it. And then the AY value you can find from this equation. So that one is at the 640 minus 170. So you will get the 470 pounds. And then box it. So we get the all unknown reactions, support reactions with this procedure. So this slide shows the practice problem. So you need to determine the support reactions, which are A, BX, and BY, because this is a roller support, and then this is a pin support. Okay, so try to follow the procedure. So draw free body diagram, formulate equilibrium equations, and determine the reactions at the support A and B. Okay, so I hope this video is helpful for you. Thank you.